Okay, so now that I got the reaction forces, I can start going around and solving the different joints. So I'd like to find an easy place to start. And you know it's an easy place to start if it's got less, if it's a joint that has only a few members going into it. And the more members you know the value of, the better. So I'm going to start with, for example, like a corner could be good. So I'm going to start with point one. Okay, so since I'm starting at point one, I'm going to redraw it down here. Point one. And I'm going to redraw it. So I'm going to draw a circle for point one. And I'm going to look at what's happening on point one. Well, we've got two kips going down. We've got A probably pushing up, and we've got B, and I'm not really sure what B is doing. I'm not sure which direction it is. So I'm just gonna leave it for now. Okay, so now I can do the sum of the forces. Let's say sum of the forces in the y direction is equal to 0. And that's going to be the same as A minus 2 kips. Okay. And those are the only forces in the y direction. So I can actually just solve for A. And I can say, well, um, move 2 kips over in the equation. And I can say A is equal to positive 2 kips. Okay. And in this instance, I can kind of tell that it's going to be in compression because it's kind of got to react against this 2 kips that's coming down. It's got to push back up against it. But I also know that it's going to be in compression because in my equation here, I assumed that it was going against the 2K, that it had a different sign than the 2K. If it was going with the 2K, I might say negative A minus 2K. But I think that they're going against each other. So that was my assumption. And because I got a positive answer, it means that my assumption was correct. So I know that A is going to be in compression. Compression. Okay, I'm going to use a color to just keep track of that. So I'm going to say that red is compression. Okay, so A is red. Okay, now I can also look at the x direction here. Sum of the forces in x direction is equal to 0, equal to, and let's see, what forces do we have in the x direction? Well, we've only got one, and that's B. There's nothing going against it. So therefore, I can just say that B is 0 if it's really the only horizontal force. It's right here in my equation. B is equal to 0. And if something is 0 kips, then it's neither compression nor tension. Okay, so you can kind of just leave B alone. Okay, so now joint one is done. And let me just box my answers. Okay, let's move on to point two. 0.2. So let's see what's happening down here at 0.2. So I'm going to start with my point. I'm going to draw the free body diagram. I think there is A. And since I know A is in compression, I know that at 0.1, it's going to be pushing up. And I know that at 0.2, it's going to be pushing down because A is in compression to be found earlier. Okay. Then I also see that RA is pushing up at this point. Say RA. And then I see that there's member C. And I see that there's member D. Okay. So now, once again, let's try and do the forces in the y direction. And the forces in the y direction are equal to 0. And that's going to be RA, it's going up, minus A. I'm saying minus A because it's going down in the y direction. And then now we've got another force. We've got, let's see. We've got C, and C is diagonal, so it's going to have an X component and a Y component. The Y component is going to matter for our sum of the Y forces. And let's take a guess here. Let's say, you know what? I think I'm just going to assume that C is in tension. Okay, let's see. I don't know if it is or it isn't, but I'm saying that it's in tension. So if it's in tension, then it's kind of pulling up. So I'm going to say that it is positive like RA, like it's acting in the same direction as RA. I'm going to say plus CY. Okay. And then I know the value of some of these forces. So I know RA from before is 3.33 kips minus A, and A is 2 kips plus CY. Now I can solve this and say that CY is going to be equal to, well, 3.33 minus 2 is 1.33. 1.33 plus CY is equal to 0. So CY is going to be equal to negative 1.33. Okay. All right. So I've got a negative answer for CY. That means that my assumption was incorrect. Okay, and my assumption was that it was in tension. Because it's negative, that means that really it must be in compression. So I'm going to try and change the direction of this arrow. Really, it's like that. And I'm going to also kind of highlight it red because that's my color for compression. And I can say compression. Okay. But CY is only part of C, right? It's just the Y component. So to get C, I'm going to think about this C component. And I'm going to redraw this. Just draw the triangle. So C And I can say CY, CX. And I know from the problem that all my angles in this triangle are going to be 45 degrees. Because the width is the same as the height. So because of that, I can say CX is equal to CY is equal to 1.33 kips. Okay. And I don't have to worry about the sign for CX and CY right now because the sign, the positive or negative, is really just telling you what direction it's moving in. Right now, I'm concerned in the values. So CX and CY are equal to 1.33 kips. How can I find C? Well, I think it'd be easy just to use the Pythagorean theorem. I'm going to say a squared plus b squared is equal to c squared. I'm going to say that cx squared plus cy squared plus c squared. And that's going to be like 1.33k squared plus 1.33k squared equal to c squared. And then put that in the calculator. 1.33. That's going to be 1.78 kips plus 1.78 kips is equal to c squared. That's going to be 3.55 kips is equal to c squared. And then c is going to be equal to 1.88 kips. Okay. And because I found before that C, from looking at CY, that it's going to be in compression, I can say that C is in compression. Okay, so that's another answer that I can box. Okay, so on this point, we got some things done, but I still see D is an unknown. So let's do D. Let's say sum of the forces in the x direction is equal to 0. And that's going to be equal to D. And then, well, actually, here, I'll say this. I'll say it's going to be CX, so the X component of C. And then there's also D. And I think that because they're the only two forces in the X direction, they're probably going to be like counteracting each other. So I'm going to say CX minus D. That's my guess. So that would be if C is going this way, D, my guess is that it's going to go that way to the right to like counteract C, to like counter it out. That's my guess anyway. So now I can solve this and say that, well, move D over, D is equal to CX. And we know CX from before is 1.33 kips. That's what D is going to be, and it's positive answer. So it tells me that my assumption was correct. And if D is going away from the point, it means that it's in tension. Since it's in tension, I'll color it blue. Good. We're getting there. So point two, joint two rather, is all done, all solved now.